Hi all, good evening. We'll get started in about a minute or so. I'm going to start this chat window and keep it by the side. It would help if you guys can say that if you're able to hear the volume and if things are fine. Right? If anyone who's already in there, hi, my name is Baskar. If you can hear me loud and clear, can you just reply back saying that it's all good so we can get started in about a minute. Right, let's get started. Good evening, everyone. My name is Baskar. I'll be running this session for you today. Briefly, introductions. I've done my CAT in 91, took my CAT in 91, joined IIM Calcutta in 92, 94. So this is basically my background. I run this company called Ascent Education, which conducts classes for GMAT under the brand name Wizako. Right. Data sufficiency is an integral part of GMAT, so that's why I'm handling this session. Rajesh invited me to do this session. Right. So the basics are over. So let's get started. The idea is CAT has, to my knowledge, in the last 6-7 years, never tested data sufficiency at all. So we could take two calls at this point. We could say that they have not tested data sufficiency for the last 7 years. They're unlikely to test it for another couple of years and basically ensconce in this comfort and leave it at this. But then CAT has this nasty habit of throwing a surprise every now and then. Way back in 95, 96, they used to have something called fact inference judgment in the verbal section. We all thought it was like done and dusted. CAT is never going to test this. And suddenly in 2008 or 9, I don't remember the year, they threw a surprise. They started testing fact inference judgment. So they have not tested in 7 years. Good chance they may not test it this year. Or there's a good chance because of that, it might appear this year. So the better thing is to basically be prepared for it. Right? So the data is insufficient as far as whether it's going to appear in the CAT this year. But those of you who are watching here because of GMAT, 1/3 of the quant questions that appear are data sufficiency question. It's an integral part of your quant preparation. You cannot wish it away the way CAT students can do it. Right? Let's get started. What I'm going to do is I'm going to share a screen right now where I'm going to walk you through the 5 answer choices. I'm going to stick to the answer choices of GMAT. In CAT, the answer choices will be down to 4. So when you write the CAT, if it appears in this year's CAT, spend about 3 to 4 minutes understanding what it is. It's worth investing that kind of time. Get clarity on the choices and then get started with the questions. Right? We'll start with the choices. Just give me a minute to share the screen with you guys. Right, let's get started with this one. I'll hide this. The choices are, there'll be 5 choices because it's a multiple choice question. The first choice is, typically, I'm just going to give you a 30-second brief about what the data sufficiency is. Any data sufficiency question is going to have a question followed by 2 statements. There is going to be statement 1 and there is going to be statement 2. Right? What we need to figure out is the information available in these statements enough? Is it sufficient to answer the question? So based on how little information is required is what sufficiency is, right? What is the least amount of information that you need to answer the question is all what counts here. If statement 1 alone is sufficient, but 2 is not, then the answer choice is A. If statement 2 alone is sufficient, but 1 is not, then the answer choice is B. If each of these statements is independently not sufficient, but if we combine the information available with these 2 statements and if it is sufficient, then the answer choice is C. If each statement is independently sufficient, statement 1 alone is sufficient, so is statement 2 alone, then the answer choice is D. Finally, if you combine the information in the 2 statements and you realize that what is available is not enough to answer the question, then the answer choice is E, right? So quick recap, statement 1 alone sufficient, 2 not, then it is A. 2 alone sufficient, 1 is not, then it is B. Together they are sufficient, then it is C. It is D. And finally, if it's not sufficient, then it is E. What I'm going to do is, I'll ask my colleagues to quickly populate the entire chat session with the 5 questions that we're going to start. We'll start with the easy 5 questions. Each of these questions should take you about a minute, not more than that. While we are doing that, I'll quickly give you an overview about how to go about a data sufficiency question, things that you need to watch out for. And at the end of the 5th minute, let's start discussing these questions. Right? I think the questions should come into the chat in a short while. I'll start with the first one in case it's going to take a little while. The first question is what is the value of n? That's the first question, right? The statement that follows. The first statement is n is greater than 10, and the second one is n is less than 12, right? That's the first statement. So just given the first statement while my colleagues are populating it with the remaining questions. First 5 questions are easy questions. Right? When you start any data sufficiency question, have certain clarity in your mind. Right? First, invest time in understanding what you need to find out. Right? If I can give you a breakup of the time that you need to spend between the question stem and the statements, it would probably be 40% of the time spend it in the question stem, 30% each for the statements. Right? Understand what you need to find out. Whenever a question in data sufficiency, as it happens in the first one, we'll discuss it in depth, but I'm just giving you an overview right now. As happens in the first one, if it is asking what is the value of n, the data is sufficient if you are able to come up with a unique answer. That is the crux of it. If you say that n is 18, n is 19, n could be 43, if you're giving multiple answers, then it is not sufficient. You need to come up with a unique value, which is when the data is sufficient. Right? So have this perspective in mind when it is what is the value of n. Second thing, there could be questions which will start with a be verb, right? Questions that could ask is, was, and does, these kinds of questions. You might ask, is the value of n equal to 14? For an is question, how would you typically answer any is question? Is questions always return an answer, which is either an yes or a no. Sufficient for an is question. The data is sufficient for an is question if you're able to come up with a definite yes or a definite no. Yes, n is equal to 14. It cannot be anything else. The data is sufficient. Watch out for this also. Many times when we get a no, we might think the data is not sufficient. Even when it is a no, the data is sufficient. We can say n can be anything other than 14. The data is sufficient. You need not even know what that n should be or what that n could be. So no is also sufficient. When is it not sufficient? If you're saying n could be 14, n could also be 17. Those are the times when the data is not sufficient. So giving you a perspective about what to do with questions which is asking you for value, what to do with questions which are like questions that start with a be verb. Be verb questions always get an answer which is yes or no. Many times it makes in that 40% of the time that I've been telling you, invest that time in understanding when is it an yes, when is it a no. Many a times we will not get this yes no property very clear. We'll not get clarity on when is it an yes, when is it a no, and that's why things go wrong. Right? So this is the basis for data sufficiency. I'll quickly walk you through with a slide the process that you need to go through it, and then we'll switch into the questions. Right? I'm going to share the screen again with you. Just give me a minute. Right. I think I'm ready to roll with this. Right. You look at a question, you spend some time on the question, you have evaluated what the question is asking you to find out. Then the first step for you is going to be to evaluate statement 1. If statement 1 can be one of these two things, if understood statement 1, it gives you an answer saying that the data is sufficient or the data is not sufficient. You've got a unique answer with it. In that case, the data is sufficient. If you did not get a unique answer with it, then the data is insufficient. So if you've invested time with statement 1 and you've figured one of these two, if statement 1 is sufficient, what could be the answer choices? We have 5 answer choices. The first one said statement 1 alone is sufficient, 2 is not. So if statement 1 is sufficient, it could possibly be an A, which states that statement 1 is sufficient. We have not yet evaluated statement 2, so we do not know what it is, but it could be an A. It could also be one other possibility, which is basically a D. D says each of these statements is independently sufficient. If one is sufficient, you've actually brought down your hit rate from 20%, from 1 and 5 answer choices, to 50%. Your answer is either going to be A or D. So the moment you realize statement 1 is sufficient, say that B, C, E are not possible. We are reducing our answer choice possibilities to A and D. Do this mechanics very, very sincerely, because many a times after having understood and evaluated things properly, people make a mistake because they do not scratch out things which are no longer the answers. If 1 is not sufficient, then obviously the remaining 3 answer choices are what we have. So your answer choice could be B or C or E. Now let's take this stem. Statement 1 is sufficient stem. In this one, we still have to figure out whether the answer choice is A or D. So how are we going to do it? Step 2, we are going to be evaluating statement 2. Statement 2 could end up being sufficient or could end up becoming insufficient. If 1 is sufficient and 2 is also sufficient, then what could be the answer? If 1 is sufficient, your answer choices were A or D. 2 is also sufficient, so the answer choice is D. If 2 ended up being insufficient, then your answer choices 1 is sufficient, 2 is not, therefore it is going to be A. If statement 1 is not sufficient, if it is insufficient, in that tree, what we'll end up having is, we'll evaluate statement 2 again here. In this scenario, statement 2 could be sufficient or statement 2 could be insufficient. We are in the branch where 1 is not sufficient, so our answer choices are basically one of these 3, B, C or E. If 2 is sufficient, your answer choice is B. If 2 is not sufficient, then we are going to combine and see whether it is still sufficient. So our answer choices are down to C or E. Only if you reach here should you combine and check out whether the data is sufficient. If the combination is sufficient, go with C. If the combination is insufficient, then go with D. Right? Quick recap, evaluate statement 1. If 1 is sufficient, choice A or D. B, C, E cannot be the answers. If 2 is also sufficient subsequently, your answer choice is D. If 2 is not sufficient, your answer choice is A. If 1 is not sufficient, rule out A, D. What we are down to is B, C or E. Quickly evaluate statement 2. If it is sufficient, answer choice is B. Otherwise, go ahead, combine the statements. Combination is sufficient, it's C, else it is E. Right? So we've done the background work to get started with the questions. We're going to stop sharing this and move on to the questions. Here are the answer choices. We'll get started with question 1. This is what question 1 is. What is N? Statement 1 says N is greater than 10 and statement 2 says N is less than 12. My suggestion is get clarity on what the question is. The question is what is N? We need to come up with a unique value for N. If I'm able to say N is equal to this one single number, then the data is sufficient. As always, we'll start evaluating statement 1 alone. It says N is greater than 10. N is greater than 10. N could be 11. N could be 101. N could be a million. So there are infinite possibilities that exist for the value of N from statement 1 alone. So statement 1 is not giving us a unique answer. So let's scratch out statement 1 being sufficient. The moment 1 is not sufficient, let's quickly rule out answer choices A and D. What we are down to is only the remaining 3 choices, B, C or E. So decide between these 3. Let's evaluate statement 2. It says N is less than 12. Less than 12, N could be 11, N could be a 5, N could be 0. Again, we have infinite possibilities here. Statement 2 alone is also not sufficient. We started the statement with 3 choices, B, C or E. If 2 is not sufficient, let's quickly rule out B. What we are down to is C or E. Let's quickly combine the 2 statements. It says N is greater than 10, N is less than 12. The temptation is to say that yes, N is equal to 11, right? If N is greater than 10 and N is less than 12, obviously there is only one number that I can think of, which is N is equal to 11. But hold on, the trap is here. No one told us that N is an integer. Between 10, a number greater than 10 and a number less than 12, there are infinite numbers. There could be a 10.83. There could be 11.75, right? There are infinite numbers between 2 integers. N could take any of those values. Without the statement or the question stem saying that N is an integer, if you thought these 2 statements together are sufficient, you would have got an answer which is incorrect. statements together are still not giving us a unique answer. So choice E is the answer. Data is insufficient. If you've got a C, just keep this in mind. The takeaway from this question is if it is too easy, then ponder for a minute. There could be a trap there. The crux of more important thing that I want you to take home is there are infinite numbers in between two consecutive integers. Do not assume a number to be an integer unless either the question stem or the statements explicitly give you that indication that it is an integer. Right? Let's quickly move on to question 2. Question 2. I love these questions which start with an S, right? These B verb questions actually make you think a lot more than questions which start with what is. Is X equal to 3? This question, obviously I mentioned the answer is going to be an yes or the answer is going to be a no. This is a very straightforward case of deciding when it is an yes, when it is a no. Yes, when X is equal to 3. No, when X is anything other than 3. X could be a 2.99. X could be a 38.43, right? Any value other than 3, the answer is no. When is it a maybe? If for some values you get X is equal to 3 and for some you get X is not equal to 3, that is when the data is not sufficient. If it is a 3 and you get an S, data is sufficient. If it is not a 3 and you get a no, data is sufficient. If you are saying it sometimes may be a 3, sometimes need not be a 3, which is when the data is not sufficient. Let's evaluate statement 1. Statement 1 tells us that X square is equal to 9. X square equals 9. What all values can X take for X square being a 9? X could be a 3 or X could be a minus 3. X square is 9 on account of both these possibilities. The question is X equal to 3? Is it a 3? Possible. If X equal to 3 made X square a 9, then the answer is yes. But if X is equal to minus 3 and on account of that X square is equal to 9, then the answer is a no. So essentially you're saying it could be an S, it could be a no. Essentially we are not giving any conclusive answer. We're essentially moving towards this maybe. The moment you say maybe, the data is insufficient, right? So statement 1 is not sufficient. If 1 is not sufficient, let's rule out choices A and D. We're down to B, C, or E. Statement 2 tells us that X is less than 0. Looks like a very simple statement. What does X is less than 0 means? X is a negative number, right? How many negative numbers are there? There are infinite negative numbers are there. So obviously to say that like statement 2, come on here, how can it give you an answer? It is also not sufficient is what I'm tending to. But hold on, is the question what is X or is the question X is X equal to 3? Keep track of the question. The question is X equal to 3? If X is a negative number, can it be a 3? Has any negative number ever been equal to 3? A negative number can never be equal to 3. So I can give an answer. X, if it is a negative number, it cannot be a 3. No, X is not equal to 3 is what I'm going to come up with. If I'm able to come up with a definite no as an answer, then statement 2 is sufficient. When statement 1 was not sufficient, we brought down our answer choices to B, C, or E. If 2 alone is sufficient, our answer is B, we'll rule out choices C and D. Right? The takeaway from this question is primarily this. The question is not what is X. The question is X equal to 3? Always keep track of the question. You do not assume this is the question or this is what we have to find out. Just keep note of what is asked and answer that question. We're going to move on to question 3. Again, the same question. Is X equal to 3? So the question part of it we can quickly skip through. Let's evaluate statement 1. Statement 1 tells us that X square equals 16. So X could be a 4 or X could be a minus 4. Either of these will land up with X square being 16. Now think about it. What is the question? Is the question asking us what is X or is the question is X equal to 3? The question is X equal to 3? If X is equal to 4, will X be a 3? The answer is a no. If X is equal to minus 4, will X be a 3? The answer is still a no. Have we got a conclusive no as an answer? Yes, we have got a conclusive no as an answer. So statement 1 alone is sufficient. Keep this in mind. If you get a no, as long as it's a definite no, the data is sufficient. No is sufficient. Maybe is the only thing which is not sufficient. So if statement 1 is sufficient, our answers are basically A or D. We are in a 50% chance right now. Let's look at statement 2. It says x is greater than 0. X is greater than 0. Can x be a 3? 3 is a positive number. We know x is a positive number. So x could be a 3. But if it's a positive number, it has infinite possibilities. It could be a 2, it could be 11, it could be a million, it could be a billion, it could be any number of values. So statement 2 does not give us a conclusive answer. It's not saying whether x is a 3. It could be a 3. It need not be a 3. So we are coming up with multiple answers. So statement 2 alone is not sufficient. So answer choices, if 1 is sufficient, 2 is not sufficient. A is the answer to this question. Let's quickly move on. The takeaway from this is basically no, right? So next one, again, a very interesting question, simple question, but a beautiful question. If star represents one of addition, subtraction, multiplication, or division, we need to find out what is 7 star 0. Statement 1 says 0 star 5 is equal to 5. What operand will make 0 star 5 to be equal to 5? Star should be a plus, which is when it's going to happen. So 0 plus 5 is equal to 5. Into division minus will not make it work. So we know star is equal to plus. What will be 7 star 0? 7 star 0 is equal to 7 plus 0, which is equal to 7. So statement 1 is sufficient. Answer is going to be either A or B. Right? This is the easier part. Done. Dusted. Most of you would have got it right. Now let's look at statement 2. It says 5 star 0 is equal to 5. If 5 star 0 is equal to 5, what could star be? Star could either be a plus or star could be a minus. 5 plus 0 is a 5. 5 minus 0 is also a 5. In that case, do we have a unique value for star? No, we do not have a unique value for star. So we can we conclude that statement 2 is not sufficient? Tempted to, but hold on. Is the question finding out what is star, or is the question finding out what is 7 star 0? The question is what is 7 star 0? Finding star is probably an intermittent step for us, intermediate step for us. So 5 star 0, if star is a plus, is going to be 5 plus 0, which is a 5. If star is a minus, 5 minus 0 is also going to be a 5. So what we essentially have is a unique answer from statement 2 also. 2 is also sufficient. Choice D is the correct answer. The quick takeaway from this is check out what the question is. What is the question you're trying to answer? Is it what is star, or is it what is 7 star 0? This is a question that can be answered with statement 2 also. So choice D is the correct answer. So move on to the last question in the easy set. What is the area of the triangle ABC is what is asked. You need to come up with a unique value for the area of the triangle. You should be able to say the area of the triangle is 45 square units, or one such number. Statement 1 gives us 2 sides. Definitely not sufficient. Without knowing the third side, we can't answer. Rule out statement 1. What we are down to is we'll rule out A and D. What we are down to is B, C, or E. Let's look at statement 2. It says a triangle is an isosceles triangle. Infinite isosceles triangles are possible. You do not have any data point. 2 alone is not sufficient. So let's rule out choice B as well. What we are down to is C or E. Let's combine the two statements. We combine the two statements. We have the sides as 5 and 10, and it's an isosceles triangle. So sides could be 5, 5, 10, or it could be 5, 10, 10. Do we have a unique triangle coming out of it? No. So again, I'm tempted to go with an answer saying that because I do not have a unique set of values for the triangle, the data is not sufficient. Hold on. This is where some amount of basics help. Can 5, 5, 10 form sides of a triangle? The basic property of a triangle is sum of two sides should be greater than the longer side. Here 5 plus 5 is not greater than 10. So you cannot form an isosceles triangle with 5, 5 and 10. The only isosceles triangle possible is 5, 10, 10. And therefore we can find out the answer. The most important thing here is don't compute that value. In a data sufficiency, what you need to be bothered about is whether you can get a unique value. 5, 10, 10 will have a unique area. Don't waste time. That would be the stupidest thing that we could possibly do, right? So if statements together are sufficient, choice C is the correct answer to this, right? So if you have shaky basics, it's going to haunt you. Don't fall prey for the fact that you'll have to compute the value. What you have to check out is whether the data is sufficient, right? Quickly, we'll populate it with the second set of questions, which are a little more difficult, therefore a little more interesting. Let's get going with that. Right, the next set Now that we have seen how to go about it, we've actually went through a bunch of very easy questions. The next one set of questions are going to be that much more interesting. So if something is too obviously right, invest another couple of minutes to check out whether what you're getting is what it should be, right? And systematically go about it. It's so easy to look at the two statements and then combine the statements and come up with an answer. You would get an answer in this, and that answer could end up being wrong. One of the most common things that I hear from people who prepare for CAT and come and start preparing for the GMAT, they say that I've got a 99.7 in the CAT quant. Therefore, quant for me in GMAT is not going to be difficult. Pretty much true. I agree with you. I'm there almost with you on that. The problem-solving part of the GMAT quant is something that you'll ace. Yet third, anything from 13 to 15 or the 37 questions in the GMAT quant are data sufficiency questions. Data sufficiency questions are not testing calculus. They're never going to ask you to find out the volume of a tetrahedron placed on top of a spherical ball. I don't even know how a tetrahedron looks. What it is always going to check out is n a positive number, is n a negative number, right? It asks very simple things, but you need to check things incisively. You should not make any unwarranted assumptions. So those of you who are planning to do the GMAT and the CAT, invest adequate time when it comes to the GMAT data sufficiency. A ballpark number, solve at least 500 DS questions. The quant problems you got a 9+ in, you will crack all of the problem solving. But sometimes that arrogance that I got a 99.5+ in the CAT quant could be the undoing when it comes to the data sufficiency. Watch out and go about it systematically. Alone first, check out whether your answer choice are going to be AD or BCE. If it is one of these two, then pick the second stem and then move on from there. Evaluate statement 2 alone. Combine the statements only when your answer choice is neither A nor D nor B. Reading both the statements together. I've told this umpteen number of times in the last 16 years I've taught people for GMAT. Will come, they'll read both the statements and then they'll say that it is C without even bothering to find out whether one of those statements could have been sufficient. Right. Let's get started with the second set. I'm going to start sharing the screen. Right. I presume you guys would have had time to go through this. We'll get started slowly with the first of the questions. What is the area of the triangle ABC whose perimeter is 30 units? The perimeter is given to us. We need to find out the area. The data will be sufficient if you are able to come up with a unique answer for this. So you need to come up with a number which says 43 square units or something. Right? Let's quickly look at statement 1. What is statement 1? It says one of the angles is 80 degrees is what it says. Perimeter is equal to 30 is a data that is available from the question stem. Whatever is available from the question stem, you can definitely use it with both the statements. You know, one of the angles, the remaining two angles, let's say this angle is equal to A. B plus C is going to add up to 100. It can break this B and C in any number of ways. It could be a 50-50, 40-60. Each of those will result in a different triangle, which means the area is going to be different. That is all the analysis you are going to do. Don't waste time trying to find out that exact number. So statement 1 alone is not sufficient. So we'll rule out choices A and D. What we are down to is choices B, C, or E. This discipline will help you keep doing this, scratch out the two choices, come back to what is still left. Let's look at statement 2. It says a triangle is an isosceles triangle. Umpteen isosceles triangles are possible with a perimeter of 30, which means you're not going to get a unique answer. Statement 2 alone is also not sufficient. We were down to B, C, E after evaluating statement 1. If 2 is also not sufficient, let's rule out B. What we are down to is C or E. Let's combine the two statements. We know one of the angles is 80 and the triangle is an isosceles triangle. Can we find out the remaining two angles? The triangle is an isosceles triangle, so two sides are going to be equal and two angles are going to be equal. If one of the angles is 80 and the sum of the other two angles is equal to 100, and we have to have two angles being same, is there only one possibility or do we have more than one possibility? That's a question. Easiest thing that I can think of is break this 100 into two parts, which is going to be a 50 and a 50. So 80, 50, 50 is definitely one possibility. If this is the only possibility, the statements together are sufficient. Take a minute, check out if there's one more possibility, or is this the only one? There is one more. Because 80 is one of the angles, can 80 be the second angle which is equal? Pretty much possible, because these two right now add up to only 160. We can have another 20 adding it up. So the triangle could be an 80-50-50 or an 80-80-20 triangle. Each of these triangles is going to have a different area. So we are not getting a unique value despite combining the two statements. So rule out choice C. We are down to E. Again, the most important thing I want to tell you is don't bother about, given this perimeter, what is that exact number that I'm going to find out? Do I use half AB sin C formula? Do I go with A by sin A is equal to B by sin B formula? None of that matters. You're not solving a problem solving question. I don't even know what is the value of sin 80, right? So what you're going to find out is the triangle unique, right? That is all that is needed to crack this question. The triangle is not unique. Therefore, we are not getting a unique answer. Choice E is the answer to this. Right? The crux of this question is the only thing that you need to ask in these kinds of questions is, am I getting a unique triangle? The triangle is unique, then don't worry. The answer is unique too. So more to the second one. This is again an area of a triangle question. Concept is simple. You need to get a unique number. You need to be able to say that the area of the triangle is 25 square units or something like that. Statement 1 says the sides are 6 and 8. Without knowing the third side, we'll not be able to find out. Don't make the mistake because you have seen 6 and 8. 6 and 8 is a part of a Pythagorean triplet. So all of us will think the triangle is a 6, 8, 10 triangle. The triangle could very well be a 6, 8, 11 triangle. 6 plus 8 is greater than 11. It is not a right triangle. It is a triangle. We know only two sides. Without knowing the third side, we will not be able to find, or we at least need to know the included angle. Statement 1 is not sufficient. We'll rule out choices A and D. What we are down to is B, C, or E. Let's evaluate statement 2. Statement 2 says that one of the angles is 90. We do not have any other information other than the fact that the angle is 90. Do not carry over information from the previous statement. Do not think the sides are 6 and 8. Please don't make these mistakes. These are mistakes that most of us make. Clear your RAM, clear your flash memory of what you read in statement 1. Read only statement 2. If one of the angles is 90, it's a right triangle. There could be umpteen right triangles. Each one has a different area. Statement 2 is not going to give you a unique answer. Rule out choice B. What we are down to is C or E. Let's combine the two statements. Now it's very promising. The two sides are 6 and 8. One of the angles is 90. Obviously, the triangle that we are talking about is a 6, 8, 10 right triangle, right? So the area can be found out. It is unique. So I'm going to go with C as an answer. Too tempting. Too tempting. Did anyone think about a possibility other than this? Is this angle 90 in between 6 and 8? If this angle 90 is between 6 and 8, then the hypotenuse is going to be 10, because hypotenuse is the longest side and 90 degrees is the largest angle in a right triangle. Conversely, what if it ended up being this way? This 8 happened to be a hypotenuse. The angle is 90 degrees. One of the sides is 6. The third side is going to be square root of 64 minus 36. Is this a right triangle where two sides are 6 and 8 and one of the angles is 90 degrees? Certainly yes. So do we have a unique triangle with this? No. Don't fall for such traps. These are the popular traps that you'll get set in data sufficiency. Because we do not have a unique triangle, the temptation was to go with the C. 6, 8, 10 is so tempting. Do not fall for it. It could be a 6 root 16, root 64 minus 36 and 8 as a triangle is a possibility. That makes it that C is not the answer. Cannot got a unique value. E is the answer to this question, right? So this is a very, very important question that will teach you a lesson. Always get your basics right. You can uniquely define a triangle if you know two sides and an included angle. What I said in the last one still holds good. Keep your basics strong. If the basics are shaky, it could come in to nail you in questions like this, right? Do not let the obvious fool you. 6, 8, 10 is not the only right triangle with side 6 and 8. That's a key takeaway from this question. So what are the third one in the set? What is the largest value of the largest of the 5 positive integers? When you read questions, keep track of these things. It is said there are 5 and these are positive integers. So values that these numbers can take cannot be negative. The values that these can take cannot be non-integers, cannot even be a 0. Right? Start with statement 1. We need to find out a unique value for the largest one. If you come up with an answer, it says the largest integer is 73, then the data is sufficient. 73 is an example. Right? Let's look at statement 1. Average is 40 and median is 40. 5 numbers. The median is 40 means we are talking about the third number carrying a value of 40. Average is 40. Some of these numbers, A, let's say these numbers are A, B, C, D, E. Right? A plus B plus C plus D plus E is equal to 200. And let's say these are in ascending order. C is equal to 40 is what I have. What I need to find out is what is the largest number. All of these numbers could have been a 40. Average will be 40. Median will be 40. Largest number will be 40. Conversely, the smallest number could be 10. This could be 20. This could be 40. This number could be a 60. And this could be a 70. Right? The average will still end up being a 40. Median is 40. What is the largest number? The largest number is 70. So we are not getting a unique value with statement 1. 1 alone is not sufficient. Rule out AD quickly. We are down to B, C, or E. Let's move on to statement 2. It says the median is 40. We'll go with the numbers as A, B, C, D, E. Median is equal to 40. Range is 70. Which essentially means that E minus A is equal to 70. Will we have a unique value for it? We will not. If I go with a 40 for A, then the range is 70. B could also be 40. C is a 40. Is a median equal to 40? Definitely equal to 40. This number, I'm sorry, this cannot be a 40. It just changes a bit. This is a 40. Let's say A is equal to a 10. And then the range ends up making this number to be equal to an 80. So 10 plus 80 is 90. 90 plus 40 is equal to 130. We need to make the sum to be equal to a 200. Remaining, I have a 70 to be broken up. That can be broken up as a 45 and a 25. Median 40, range 70. What do we have as the largest value? Largest value is equal to 80. I can make this number as a 5. Retain everything here, make this a 75. Now reduce 5 from both of these. I can add 5 to each of these, 30, 40, 50. I'm not getting a unique value with this either. So essentially, knowing the median and the range is also not sufficient. We are not getting a unique value for the largest value. So statement 2 alone is also not sufficient. Let's rule out choice B as well. What we are down to is C or E. Combine the statements. Combining the statements, average should be 40, which means sum should be equal to 200. A plus B plus C plus D plus E is equal to 200. Median is 40. Range is equal to 70. The numbers that I took in the last example will hold good here also. Let's go with a 10 and an 80. So what we have is 120, 130. 70 to be split between these two numbers. We'll make it a 25 and a 45. This is one possibility. All conditions holding good. Average 40, median 40, range 70. Let's reduce each of these numbers by a 5. So essentially range is still a 70. Keep the median at 40. Because we have taken 5 from each of these, we have brought down the sum by 10 if we went with a 25 and 45. Add that 5 to both these numbers. So essentially, we'll still end up with an average of 40, median 40, and the range is 70. Do we have a unique value for the largest number? Despite combining, we do not have it. So statement C is not the answer. E is the answer to this question. The crux of this question is what you have to look for is look for what I would call as a counter example. Look for one set of values which will satisfy everything that is stated in the stem and the statements, which will give you one value for the largest number. If you can find a second value, which is a counter example, then we are saying that all these things are holding good. I'm still not able to find a unique value to it. Therefore, these statements together are not sufficient. I'm going to state something which is very obvious. A counter example works when a counter example exists. What it means is, if you are not able to find a counter example, do not decide that the statement is sufficient. It possibly could mean that you are not able to find a counter example. A counter example may exist, right? If you find a counter example, good, you have nailed it. You're saying that the statement is not sufficient. But just because you've not been able to find a counter example doesn't mean that one does not exist, right? Let's move on to the next one. It's a beautiful question. Is x cube greater than x square the question? Is question. We'll have to come up with an yes or a no as an answer. Quickly, when is it an yes? When x cube is greater than x square, the answer is yes. When is it a no? Obvious one is x cube is less than x square. Hold on for a minute. What if x cube is equal to x square? If x cube is equal to x square, the question is x cube greater than x square? It is not greater. So even when it is an equal, the answer is going to be a no. So yes, when it is greater, no has two possibilities. It could be it's a less or it could be equal. Right? Keep this perspective in mind. Let's quickly start with statement 1. says x is greater than 0. Oh, one other thing. Just wanted to walk you through this fact quickly. We'll take a minute for it. The ascending order of x square, x cube, x power 4, x power 5 is not going to be x square, x cube, x power 4, x power 5 for all numbers. It's going to be different for the following intervals. I want you to make a note of these intervals. You don't need to remember the ascending order exactly. Right? The first of the intervals is when the number is a negative improper fraction. Any number that lies between minus infinity and minus 1. For all of these numbers, it will behave in one fashion. We'll just quickly walk you through one part. X square and x power 4 for negative numbers will be positive. X cube and x power 5 for negative numbers is going to be negative. So obviously, x cube is not going to be greater than x square. So that's one hint for you. Try it at your time. Basically, take an x is equal to minus 2. Check out what is the ascending order of these four numbers for a value between minus infinity and minus 1. These are all negative improper fractions. On the number line, these are the numbers in the first interval. The second interval is negative proper fractions. These are numbers between minus 1 and 0, right? Something like a minus half. Here, the ascending order is going to be a completely different set of, order is going to be different. Again, try it at your time. Check with x is equal to minus half, right? Third one is for positive proper fractions, something between 0 and 1. Here, it's going to behave differently. For example, x square is a 1 by 4. X cube is, when x is equal to half, x square is 1 by 4. X cube is 1 by 8. X cube is half of 1 by 4. So it's going to be lesser than 1 by 4. So x cube is lesser than x square in this interval. And it's going to behave differently between 1 to infinity. So you'll have to remember these four intervals. You don't necessarily have to remember the ascending order per se. Minus infinity to minus 1, minus 1 to 0, 0 to 1, and 1 to infinity. Right? Let's get started with statement 1. It says x is greater than 0. What all intervals do we have to pass through? We'll have to pass through the possibility of x lying between 0 and 1. And for x between 1 and infinity, there's one more that comes in between. What if x is equal to 1? If for all of these possibilities, we get a definite yes or a definite no, because we're talking about is questions. If you get an yes, 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 data is sufficient. If you get a no, 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 data is sufficient. If you get yes and no, data is not sufficient. Between 0 and 1, is x cube greater than x square? X cube is 1 by 8 if I take x is equal to half. X square is equal to 1 by 4. X cube is not greater than x square. So answer is no in this case. Between 1 and infinity, let's go with a 2. 2 cube is an 8. 2 square is a 4. Is x cube greater than x square? It is yes. Sometimes yes, sometimes no. Statement 1 is not sufficient. Rule out AD. What we are down to is B, C, or E. Let's quickly look at statement 2. X is less than 1. Again, let's write through all of those possibilities. Less than 1 could mean between x lies between 0 and 1, which is a possibility. X could be a 0. X could lie between minus 1 and 0. X could be a minus 1. X could lie between minus infinity and minus 1. So we have 5 things to check out. Unless we get a uniform yes or a uniform no, data is not sufficient. Between 0 and 1, x cube is less than x square. We've seen it with the last statement. So the answer is it greater? No is the answer. When x is equal to 0, x cube equals x square. So the answer is no, it's not greater. All these three I'm going to combine and finish it. In all of these cases, x is negative. If x is negative, cube of a negative number is negative. Square of a negative number is positive. X cube is going to be lesser than x square. The answer is a definite no. So if x is less than 1, x cube is definitely not greater than x square. We got a conclusive answer. So statement 2 alone is sufficient. 1 was not. Choice B is the answer. Right? Once we're done with the session, we'll be hosting it on YouTube. This part alone, if you want, I would definitely recommend revisit this. Right? This is a beautiful question. Because we say x is less than 1, we'll think that there are so many ranges to go through. And how can we have a uniform answer? We've had a uniform answer. Right? Quickly, what I want you to keep in mind is the answer to the question unique is what you need to check out. Do not bother about greater than, less than, equal to. Is it yes? Is it no? That's what you need to keep in mind. And remember the 4 intervals in which the exponents of numbers, the order in which the ascending order keeps changing. Right? So done with the medium set. Quickly stop sharing and then we'll look at the hard set. The hard set is going to be that much more interesting. Right, guys? I think by now you'll have the hard questions also populated. Those of you who have got the web page, go to the hard set. There are 4 or 3 questions in that. Quickly solve them. We'll get back to the screen sharing and then look at those questions. Hard questions, every time something looks obvious, keep questioning it. Keep track of the fact that, does it say that the numbers are positive integers? Does it say that the number is an integer? Do not assume anything. The one thing that can undermine every effort that you have done in data sufficiency is making unwarranted assumptions. Avoid it at all cost. If you're thinking a number to be a 3, also think about the number being a -3. For a lot of questions, many people have asked me, how do you find out a counterexample? Questions in number properties, questions in inequalities. A beautiful way of finding out counterexample is basically this. Remember this acronym, FNZI, F-N-Z-I, right? This is basically look for a counterexample in a fraction. Don't always think of a number to be an integer. It could be a -0.5, it could be a +0.5, 3.2, right? Look for decimals or fractions. Next, look at negative numbers. Then come to 0. Will it work with 0 also? A counterexample can happen when you think of the number to be a 0. Finally, look at integers. So fractions F, negative numbers N, Z for 0, and I for integers. So if you have to look for a counterexample, FNZI is the way to go about it. Let's look at the hard question. Again, going to start sharing the screen. Getting into geometry, more geometry. Interesting question. Is the quadrilateral ABCD a parallelogram? Yes question. So we need to come up with an yes or a no. If you figure out that the quadrilateral is a parallelogram, then the answer is sufficient. It's an yes. If you say that it cannot be a parallelogram, even then it is sufficient. But if you say that sometimes yes, sometimes no, then the data is not sufficient. Quick properties of parallelogram. Opposite sides are parallel. Opposite sides are equal. Opposite angles are equal. Adjacent angles are supplementary. Their diagonals are unequal. Diagonals bisect each other. They do not bisect at right angles. These are the properties. For anyone who is not aware of it, we've done a quick run through with it. Right? Let's look at statement 1. It says a pair of opposite sides is parallel. It looks like it's mimicking what I just said. Right? Properties of parallelogram, I said opposite sides are parallel. But hold on, the statement has some catch to it. It's saying a pair of opposite sides is parallel. We do not know whether both pairs of opposite sides are parallel. That's a catch to this. So it could be a parallelogram, very well, yes, possibility. But it need not be a parallelogram also. These two sides are parallel, while these two are not parallel. It could very well be a trapezium. So the catch is, it doesn't say the opposite sides are parallel. It's saying one pair of opposite sides is parallel. It doesn't even say only one pair. If it said only one pair, I would have said it's not a parallelogram. A pair is parallel. Good. Could be both pairs, could just be one. So we are not coming up with a definite answer. So statement 1 alone is not sufficient. Rule out choices AD. What we are down to is B, C, or E. Let's look at statement 2. It says a pair of opposite sides is equal. Again, it looks like it's mimicking what I said. I said opposite sides are parallel, opposite sides are equal. I said opposite sides, which means both sets of opposite sides are equal in a parallelogram. Here it says a pair is equal. It could very well be a parallelogram, because a pair of sides is equal. In a parallelogram, a pair of sides are equal. But it could very well be something like this. These two sides are equal. Let's say this measures x, this also measures x. In this case, these two sides are opposite sides are equal, but it is definitely not a parallelogram. So this again states that you have to look for ways of finding out whether the information is exactly as how the definition gave it, or they've added something here which tweaks it to make the answer as a no. Statement 2 alone is not sufficient. We'll rule out answer choice B. What we are down to is C or E. Combine the two statements. The pair of opposite sides is parallel and a pair of opposite sides is equal. Looks like this is promising, right? Pair of opposite sides are parallel, and the pair is also equal. Is it possible to draw anything at all which is not going to be a parallelogram other than that will satisfy both these conditions? Looks like not possible. Opposite sides are parallel, right? These two opposite sides are parallel. Opposite sides are equal. These two are not equal. But what if I make these two sides as equal? This is a trapezoid. This is an isosceles trapezoid. For an isosceles trapezoid, these two opposite sides are equal, and these two sides, opposite sides, are parallel. So from this information, it could either end up becoming a parallelogram or it could become an isosceles trapezoid. Despite combining, we still are not able to decide whether this quadrilateral is a parallelogram. So choice E is the correct answer to it. So crux of this question is, when it comes to geometric questions, just get your basics in place. Look for every possibility that could make it not be a parallelogram. Right? If all possibilities are exhausted and it still ends up being only a parallelogram, if it's adamant about being a parallelogram and you can't find anything else, only then the data will be sufficient. The key takeaway is a pair of opposite sides are parallel and equal is true for a parallelogram. But a pair being parallel and pair being equal, if it is not the same set that we are talking about, then it is not a parallelogram. Right? Keep this in mind. It's a brilliant question. Let's move on to the next one. Moving into number properties. A lot of data sufficiency questions revolve around number properties and inequalities. Let's spend time on this. What is the reminder when n is divided by 14? Again, what is question? You need to be able to come up with a unique answer, which is when the data is sufficient. You should say that when I divide n by 14, the remainder is equal to 4. You should come up with one such number. You can even say that n is divisible by 14, the remainder is 0. Perfectly all right. You cannot say that the remainder could be a 4, the remainder could be an 8, then the data is not sufficient. Start with statement 1. It says n divided by 28, remainder is 20. Whenever you see remainder questions, get this thing in mind. Always get to the standard framework for reminders. Reminders, you're dividing n by 28. There is going to be a quotient q, and they're saying the remainder is equal to 20. So n is nothing but 28q plus 20. Right? Get used to these things. Now we'll have to find out the remainder when n is divided by 14. So essentially, you'll have to find out the remainder when 28q plus 20 is divided by 14. 28 is divisible by 14. So any multiple of 28 will be divisible by 14. So this part is going to give us a remainder, which is 0. So only thing that we'll have to bother about is, what is the remainder when 20 is divided by 14? The remainder is equal to 6. So the final remainder is a unique number, which is 6. So statement 1 alone is sufficient. Our answer is either A or D. To decide between these two, let's look at statement 2. N divided by 7, the remainder is 6. N by 7, let's take the quotient to be a q. Remainder is equal to 6. That's what it says. Quickly, the standard framework, n is equal to 7q plus 6. Pretty similar to what we did in the last statement. N divided by 14, what is the remainder? 7q plus 6 divided by 14. Is 7q divisible by 14? Sometimes yes, sometimes no. If q is equal to 1, it is not. If q is equal to 2, 7q is divisible by 14. So even multiples of 7 are divisible by 14. So we do not know whether it is divisible or not. So if q is equal to 1, I get an answer which is equal to 13. If q is equal to 2, I get an answer which is 6, which means you don't have a unique answer with this. Statement 2 alone is not sufficient. 1 is choice A is the answer. Want to leave you with a key takeaway. I'll read it out in the next slide. The remainder is unique if the second divisor is a factor of the first one. Look at statement 1. We found out n divided by 28. Remainder is equal to 20. Our divisor was 14. The second divisor is a factor of the first one. The remainder is unique. Statement 2, we had n divided by 7. We had remainder is equal to 6. Our divisor, second divisor is a 14. If the second divisor is a multiple of the first one, the remainder is not unique. Right? So keep this as a guideline whenever you have a question of this kind. Let's move on to the next one. If n is a positive integer, is n square divisible by 48? This is again a brilliant question. We need to find out n square, is it divisible by 48? In all of these questions, starting point is quickly prime factorize 48. 48 prime factorizes as 2 power 4 into 3. Right? This is what we have. We know n is a positive integer. If n is a positive integer, n square when prime factorized will have to have all of its prime factors raised to powers which are even. N square contains a 2 power 4 and a 3. Otherwise, it cannot be divisible by 48. That is established. Which means n square has a 2 power 4 into 3. If n is an integer, this 3 cannot have an odd power. It has to be a 3 square. So n square, though it is divisible by 48, is what this question states or is asking us to find out. We're essentially trying to find out whether n square is divisible by 2 power 4 into 3 square. Which translates to the fact of finding out, is n divisible by 2 square into 3? That is what we are trying to find out. Invest time, I said 40% of the time, in rewriting the question was, is n square divisible by 48? What it actually wanted us to find out is n divisible by 12? So if from the statements, if we're able to figure this out, then the data is sufficient, right? So rewriting this way makes life that much simpler. So look at statement 1. It says n cube is a multiple of 24. Quickly we'll write out what 24 is. 24 when prime factorized is a 2 cube into 3. We are saying n cube contains 2 cube and a 3. N is an integer, which means n cube needs to have all its prime factors raised to powers which are multiples of 3. 2 is a power of 3. The power of 2 is a 3, so no issues at all. But power of 3 as it stands right now is a 1. That is not tenable. So it has to be a 3 cube, which is the only possibility. So if n cube is divisible by 24, it essentially boils down to the fact that n cube is divisible by 2 cube into 3 cube. So what does statement 2 essentially tell us? It says that n is divisible by 6. What do we have to find out? The rewritten version of this is n divisible by 12? Our question. We know n is divisible by 6. Can we determine that n is divisible by 12? 6 is divisible by 6. It's not divisible by 12. 12 is divisible by 6. It is divisible by 12. So we're not getting a unique answer. Statement 1 alone is not sufficient. Rule out AD. What we are down to is B, C, or E. Let's look at statement 2. It says n is a multiple of 18. Brilliant. What do we need to find out in the rewritten form? We need to find out, is n divisible by 12? If n is a multiple of 18, is it divisible by 12? 18 is a multiple of 18. Answer is no. 36 is a multiple of 18. Is it divisible by 12? The answer is yes. So if a number is a multiple of 18, should it be a multiple of 12? Maybe, maybe not. 2 is also not giving us a definite answer. Let's rule out B. What we are down to is C or E. Combine, we have a lot of data. Let's see if it makes sense. Statement, the question I'm going to rewrite, is n divisible by 12? Statement 1, rewritten information, n is divisible by 6. Statement 2, n is divisible by 18. If n is divisible by 18, definitely n will be divisible by 6. So this is a redundant information for us right now. So what we have is n is divisible by 18. Is it divisible by 12? If statement 2 was not sufficient, even despite combining, it's not going to be sufficient. Together, the statements are not sufficient. E is the answer to this question. So the crux of what I want to leave you with, the takeaway from this question is restate what is to be found out. Restate the statement to make sense. If it says, is n square divisible by 48? Essentially, it boils down to, is n square divisible by 144? Translating to, is n divisible by 12? Move on to the next one. So again, it's a beautiful question. Modulus and inequalities is a potent combination. Is modulus of A greater than modulus of B the question? If you come up with an answer which is a definite yes, good. When is it an yes? Modulus of A is greater than modulus of B. When is it a no? By now you guys should have got hang of it. Modulus of A is less than modulus of B. Definitely no. Less than or equal to, even then it is a no. Statement 1, A is greater than B. If A is greater than B, modulus of A may or may not be greater than B. Quickly run through it. 4 is greater than 3. Modulus of 4 is greater than modulus of 3. This is A, this is B, this is modulus of A, and this is modulus of B. 4 is greater than minus 4. Modulus of 4 is equal to modulus of minus 4. So it is equal. In this case, the answer would have been yes. In this case, the answer is no. 4 is greater than minus 100. Modulus of minus 4 is less than modulus of minus 100. So if A is greater than B, is modulus of A greater than modulus of B? I do not know is the answer. Sometimes yes, sometimes no. Statement 1 is not sufficient. Let's rule out A and D. What we are down to is B, C, or E. Move on to statement 2. A plus B is less than 0. Sum of these two numbers is negative. When is it possible? It's possible when both A and B are negative, or one is positive, one is negative. What we need to find out is the magnitude of A greater than magnitude of B. It could pan out any which way. Minus 4, minus 3, the sum is less than 0. Modulus of A is greater than modulus of B. Minus 3, minus 4 is also less than 0. Modulus of A is less than modulus of B. Statement 2 alone is also not sufficient. Let's rule out statement. What we are down to was B, C, or E. Cancel B. What we are down to is C or E. Combine the statements. One way is to by taking numbers and figuring this out. I'm going to walk you through an alternative, which is algebra. If A is greater than B, it boils down to the fact that A minus B is greater than 0. That's what statement 1 is. Statement 2 is A plus B is less than 0. We have a number which is greater than 0. We have another number which is negative. A positive number and a negative number, if I multiply it, I'll get a number which is a negative number, because a minus b is positive, a plus b is negative. Positive into negative will result in a value which is negative. A minus b into a plus b is nothing but a square minus b square, which is less than 0. So what we get from these two statements is a square is less than b square. If a square is less than b square, obviously modulus of a is going to be less than modulus of b, because the square of this number is less than the square of the other number. When you're looking at the magnitude, a larger magnitude square will have a larger magnitude number, will have a larger magnitude square. That's the gist of it. By combining the two statements, I can conclusively state that modulus of a is not greater than modulus of b. Come up with a definite no. Statements together are sufficient. C is the answer to this question. Right. Key takeaway: if modulus of a is greater than modulus of b, then you can conclude that a square is greater than b square and vice versa. Right. Done with the hard set. I think we are running out of time as well. We'll quickly go through the very hard set and look at those questions and wrap it up. Right. Is the positive integer p prime the question? It's a beautiful question. It says that 2 power p minus 1 is prime. 2 power p minus 1 is prime. What does it essentially mean? If p had not been a prime number, let's start with it. Let's pick a number, something like a 10. 2 power 10 minus 1. Let's check out whether that could be prime. 2 power 10 minus 1 can be written as 2 power 10 minus 1 power 10. So this is of the form x power n minus y power n, where n is even, which essentially means that this can be written as x minus y into something. That is something which I can do. So this number, this 2 power 10 minus, okay, we'll just take a slightly different approach. We can write this as a 2 square 2 power 5 whole square minus 1 power 5 whole square. We'll write it this way. So got this number as I'm making it easier, x square minus y square format, which essentially will translate into an x plus y into an x minus y. So this is essentially going to be 2 power 5 minus 1 into 2 power 5 plus 1. Will this number ever be a prime number? Because 2 power 5 minus 1 is a 31, 2 power 5 plus 1 is a 33. So 31 into 33 is going to have a factor which is 31, 33, 1 and some other number. So if p is a composite number, it will end up splitting in this way that this part can never be prime. Unless 2 power p, where p is prime, p is a prime, the resultant value cannot be a prime number. So if 2 power p minus 1 is prime, we can immediately conclude that p is prime. Statement 1 alone is sufficient. Choices are either A or D. Look at statement 2. Statement 2 says that p plus 4 is a perfect square, right? So p plus 4 is equal to an n square for us. So p is equal to n square minus 4, which is n square minus 2 square. So this essentially translates to a form of n plus 2 into n minus 2. Something that's of the form n plus 2 into n minus 2, can it be a prime number? Temptation is to say no. The only case where this exception will happen is when n minus 2 is a 1, which is when n is equal to 3. So if n is equal to a 3, this is going to be a 1 and this is going to be a 5. So this case, if p is a 5, p plus 4 will be a perfect square and p will be a prime number. For all other values, if p is of the form n square minus 2 square, it's not going to be a prime number. So we have infinite cases where it is not prime and one case where it is prime. That is enough to spoil the broth. So statement 2 alone is not sufficient. Answer choice A is the correct answer. Okay. We'll take a 2 to 3 minute pause and then resume the session at the end of it.